So welcome to the Node.js build working group meeting for December 1st, 2020. We will follow the agenda that was tagged in issue 2483. Does anybody have any announcements they'd want to share before we get started?
Yeah, I have one. Just as an FYI, the Orca cloud will go down on December the 10th for about 24 hours, which means we'll have a massively reduced Mac testing infrastructure. We should still be able to do some testing and releases, but I've scheduled it for after, I think it's a 15 release goes out that week. So they're doing it next week. Um, be prepared for very little Mac testing while they migrate us to a newer cluster.
Yeah, and to be specific, it's just us, not their whole cloud, just where that's a transition for us. Okay, any other announcements? If not, let's move on to the sole issue we have. So it may be a short meeting, but it's Apple Silicon Builds 2474. Ash, do you want to take that one away?
Still need to get the DTKs working. I did have a crack at it. Was it last week? Facing some issue. I need to edit the build because things like Brew all of it. The entire ecosystem's in a bit of a mess. So I've kind of been able to get them going. They're failing at the moment because I haven't got Ccache on there, and the job's hard coded to use Ccache. So I just need to crack out some time to either compile Ccache by source or just remove it from the job for the moment. The machine should be fast enough to survive without it.
So that's
That's
because
the
we needed to bring them up to the latest OS or whatever, right?
yeah. As I said last meeting, I managed to brick two DTKs by running a Mac update, which was a common fault. So that's put us further back than we were beforehand. So I just need to bring them up and running. Uh, Spoke to Mac Stadium. They have the M1 Max coming in, but obviously their paying customers are first in line. So they said that if they ever have any spare capacity, we will get some, but we will keep the DTKs for a little while because Apple was struggling to meet demand with the releases, so they're not pulling them back as soon as we thought. So we still should be good for a little while.
In terms of the DTKs, and there's no reason why, like, I guess my understanding is we can build on our existing Mac machines, like the fat binaries, and just then
Uh,
test on the DTKs.
yeah, so I don't know if people have been seeing, but we've been getting lots of reports back um, into issues. The translation layer seems to work, so people are just running the ones we built on an Intel Mac, and it seems to work for 15. So at the moment, Node works in quotation marks. So people just need to use the translation layer. Natively, only 15 and above is supported because of the V8 version needed. So just as an FYI, if anyone ever mentions it, we don't even support experimentally in anything below 15. They shouldn't be building on it. That will
Sorry,
save them a
that's
headache.
with the translation layer or without?
That's just building natively. So if you're
Okay, right,
building an
right,
ARM
okay,
binary, but
right,
the translation layer, everything should work.
right, okay.
Apparently, with Rosetta, the translation layer, that performance has been decent too. So
Yeah, we've been hearing. I've heard that it's pretty good. So yeah, I think we're still on targeting. Is it 16 next we're targeting? So I need to try and carve out some time this week. Been a bit busy with the metrics works. What I've been busy with. So I need to carve out some time, try and get at least one of them back in, so we can start running tests and people can start looking at them in the public.
Right. I guess, and there's some we still need to do the work to figure out how to build fat binaries and all that, but it doesn't sound like we're not. There's no major rush on that front, right?
No, I wouldn't say so. The whole ecosystem in its own is in no fit state, which is why Apple put so much effort in with the translation layer. So
Right.
there's no big rush. We're not horrendously breaking anyone yet.
Yep. Okay.
I mean, there will be a PR issue as time goes on where the dominoes fall and Node is not fallen. So
Is that a
I think
PR issue for us or for Apple?
I think it's for the project for Node.
Yeah.
Because
Okay.
like it's and Apple there's this inevitability about M1 and Apple Silicon. It's happened and it's going to continue to happen, and so things have to fall in line, and you can't just hold back. So these dominoes will begin to fall. You'll see. I think Homebrew is making progress if they haven't already done it. I saw something the other day about that. And there's going to be other ones that just fall in line, and then Node will end up being, the risk is Node will end up being one of those ones that, oh, you can't get native Node, you have to build it yourself. So there is a PR risk. I think maybe that's, the TSC can consider that one. It's not really, that doesn't bother me so much, but it is certainly there.
Yeah, how soon do you think that might be, just out of interest?
I don't know, because I'm not using Apple Silicon. It's like I'm definitely not going to adopt that early.
Right.
But so I'm not as deep into that cultural thing, but there will be increasing pressure over time of, hey, everything else is well. Like Electron is great. Like they were quick because Apple really helped Electron get over that hurdle. So what's the excuse for Node if Electron's doing binaries, native binaries? So yeah, a lot of this comes down to JIP versus GN. Just the whole tool chain that Node is lumped with just sucks. And this is showing the brittleness of it.
But I mean, it doesn't. There's no necessarily development work that needs to take place, is there? Like,
there is. So there's but it's all on the tool chain side. So it's okay. Well, I've got a PR into JIP next.
Okay.
PR number. I was just commenting on number 78 in JIP next, and that is a pure hack. It's getting approvals there because we've got no better ideas, and we don't really care for this code that much. It's like we make it work, and so this is a make it work edition. So, but this is a step towards getting it's like a piece of the puzzle. So it's and all this change is doing is disabling some flags that JIP will set when compiling, with the theory that the best way to achieve this is going to be to enable the right flags from outside of JIP. So we force JIP to create makefiles that don't have these hardwired flags that it's currently doing for macOS. And then from outside of JIP, we override and put in some flags that we want to do cross-compile. But even that's a hack. Like that'll end up having to go in the makefile somewhere, and it's just going to be, we're going to be abusing JIP to get this done.
And you're talking about for add-ons, right?
Well, add-ons are a different story, and I haven't really even thought that much about that. But that will definitely come into play when people want to do add-ons for Node JIP. What is it going to compile with? I think, though, that it should be it should be okay when you are compiling an add-on natively in that's not emulated in there. So once you've got a built node that is not emulated, your add-ons should compile fine because the ARM64 flag will get through to the Arch specifier. That's fine. The problem we have is that we need to do cross-compilation to get our fat binaries.
Right. Okay.
So we've got to build on an x64 machine, and we've got to build the x64 version, and then we've got to build the ARM64 version in parallel, and then smash them together. And it's that cross-compilation picture that is missing. So the trick will be, we've got to make that work, and that's going to require lots of hackery in the makefile. At least this is my idea for how we proceed with this: is we get these hacks done in JIP, and then hacks done in the makefile, make it work, and then we can make it nicer later on if we have a path to doing so. I don't see an obvious path to doing so, but it might involve making JIP more intelligent if somebody has the patience and the Python skill to go through that.
And over time, the problem goes away once the transition's complete, right?
Well, the problem goes away because we make it work. And so for us, for what we're concerned about pushing these binaries out, the problem's gone away because it just works. And it's not pleasant, but it works. We have a bunch of stuff that's not pleasant, but works. And we survive. But the tricky bit is going to be when people start coming to us and saying, we want to cross-compile our add-ons as well. So add-on authors saying, I want to build binary, pre-build binaries on my x64 for ARM64 Mac OS. And when we've hacked JIP to work for this case, we're going to have to say, well, you're going to also have to hack it in this same way. And here's the flags you have to provide to the whole toolchain to make it work.
Right.
That will work, but it's like baking in the hack. But I see this as more of a legacy of being lumped with JIP in a way that we're maintaining JIP, we're not improving it. It's not a future-proof toolchain.
Right.
So, and this is just really exposing the raw end of that. And unless somebody shows up that cares deeply about macOS and Xcode and Python and toolchains, it's a very unique combination of things,
right.
and gets in there and improves the whole Xcode emulation section of JIP. I just don't see that happening because that file rarely gets touched. It's a lot of attention goes into the Linux side of JIP, but not much else. Well, and Windows, but certainly not Mac OS because it's just worked until now and it's been uncomplicated, but it's suddenly complicated.
Right. Okay. Got it.
The alternative version of this future is that x64 Mac OS disappears quickly and all we care about is ARM64 and nobody needs to cross compile.
Right.
That's an alternative future where everything just works out.
That's where I was like, eventually we get there. And the fact that they were hacks doesn't matter anymore because they go away, right?
I think so, but we were making fat binaries for Node all the way up until Node 012 for x64 and i386.
Yeah, okay. So it was quite a long time.
Yeah, I don't know what the timeline is for Apple, but maybe it's quite rapid. And maybe we treat it like we've treated that the minimum supported version thing, where we've actually been fairly aggressive with Mac OS. It's like most people don't run old Mac OS, and so maybe it'll become like that with the hardware. Like, okay, you've got a MacBook that's 5 years old. What are you doing? Like, maybe that's the attitude we can take. I don't know. I don't know if that's realistic.
That's a little harder because the OS upgrade is free, isn't it?
Yeah, but it'll stop being x64 at some point. Like they've been very aggressive with their iOS updates. You can't put iOS on older phones.
Yeah.
Will they do the same thing with x64 updates? Anyway, this is all hypotheticals for now. The immediate path is this is my theory anyway, my idea. Let's make these hacks work just to get it out the door. And then if we have to clean up the hacks, then so be it. As long as we don't lock ourselves into something that's terrible. There's some discussion in this JIP issue about, is this going to cause some weirdness? And I don't think it is. All I'm doing is disabling things. I'm actually pulling things out. I'm not adding in new complexity. I'm saying, let's disable this complexity so that we can add the complexity in from outside. I think that's a safer path to doing something immediate. And if we want to add the complexity in later, then that path is wide open for it. The other fly in this ointment is that I'm a bit time constrained. Right now I've got a huge GitHub backlog that I'm still working through, and so I don't exactly have tons of bandwidth to make this happen.
But if there's people who think it should happen sooner than later, they could get involved and help to move that forward.
I'm certainly willing to talk through details with people. If other people are keen to push it harder than me, but otherwise I'll chip away at it as I've got time, and pull in, request help where I can. but there's going to be some really awkward hackery around the make file. It's going to be ugly. And maybe that'll have to spill over into the release machine where we're doing environment variable hackery. So that'll be an interesting discussion when we get to it.
Mm-hmm. I guess it's just, yeah. So, okay, so now I understand why JIP is causing us grief in terms of the fat binaries versus just regular compilation.
Well, this is one piece of the puzzle I figured out that explains most of it. So JIP used to work making fat binaries for the before when there was 64-bit and 32-bit. And the only reason it worked is because you could do this all on an x64 machine, and the things that Node builds along the way that is tooling for the build, like it builds a bunch of things that get used to do the build, like it builds its own build executables, like the ICU compiler, and there's a V8 component, and there's a bunch of other things that make these binaries that get used in the build process. And that's always been a problem for cross compilation. So that's why we have the CC host and the CC target environment variables that you can set on Linux, where you can say, if you're building something that has to run on the host, then use this compiler and these compiler flags. And if you're building something that's for the target architecture, then build with these. And the Node build has to switch between those things, because sometimes it's building binaries for the build process that it has to run on the host architecture. Now that was fine previously for macOS, because it didn't matter what architecture you built it on for the host if you were doing it on x64, because you could build all of those host binaries in 32-bit and they would still run. So it never needed the ability to switch between host and target. It just did it all in target. So you could say build with Arch i386 and everything would be built 32-bit. But all of those host binaries that needed for the build process would still run on the architecture because it was still fine. We're in a situation now where the immediate plan is to build these on an x64, and we have to differentiate between the host and target architectures, because we can't have components of the build that are built for ARM64 that we need to run on x64. We can't build the ICU tooling that compiles whatever that thing is that ICU needs as ARM64. It has to be compiled as x64. So we have that's the problem and there's actually to-do notes throughout the Xcode emulation code in JIP about this kind of thing, where we do need to differentiate these things, and we just have no signal in there to do it. Like it's sort of in there for Linux, but with Linux there's some other things that make it less complicated. So there's this Arch flag that is just thrown in for every compile on every object compilation on macOS, and that Arch flag is whatever the destination architecture is that you're building, and that's why it doesn't work, because you have to build these intermediate things.
Like the cross compilation for our ARM targets would have some elements of the same problem, right?
Yep, and that's why we have these two. If you look into the scripts for the ARM v6 and 7, which we're just doing v7 now, we have two compilers in there that we specify. We specify the host compiler and the target compiler. And the host compiler will do native x64 binaries. And the target compiler will do ARM v7. But all of that logic goes through the Linux path in JIP to build those make files. Whereas in JIP for OS X, it has to write Xcode compatible make files. And so it's got a different path. And so all of this logic is in this Xcode emulation file in JIP, where it's all around how Xcode handles things and all the flags that Xcode needs. And so it just hasn't been tended to or cared for. Yeah.
So in the past, if the fat binaries used to work because you could run the i386 binaries on x64, is it theoretically possible to build Intel binaries on an ARM on Apple Silicon? Because Apple Silicon can run the ARM binaries and the Intel binaries through the Rosetta layer.
Yes, that's theoretically that is a path we could try and pursue, where we just switch it, where we switch our release binaries over to Apple Silicon, and then cross our fingers and let Rosetta handle x64 components of the build. That is a possibility. I think. I don't know.
Yeah.
I don't really know how the emulation layer gets invoked. Does it, if you run in an x64 session? No, if you run in a native session, an ARM64 session, and you throw it an x64 binary, is it happy with that? Does it switch seamlessly?
You have to pass it the command to tell it what it is. I believe you have to specify what the architecture is.
We may have the problem still of having to hack the Xcode emulation thing in JIP so that those flags get passed down into the make files. It would be interesting to test that, given access to Apple Silicon, because that could be a shortcut path. But what we'll still end up with is the case where people are in the next year or two are wanting to cross-compile on GitHub Actions or wherever else they're cross-compiling their pre-build add-ons, and they've got the same problem.
Yeah.
Maybe that goes away. Maybe we say, no, it's not possible. But yeah.
Well, at least for add-ons, we also need to look at it, but you don't have to use JIP to build add-ons. There are possible mitigations there.
That's true.
We could push people towards things like CMake.js and stuff, if that handles cross-compiling better on Macs. I don't know.
There's certainly incentive here for, there's an opening in the market here for either the ecosystem to come up with better add-on tooling, or maybe there's some pressure here for the Node project itself to push harder on the toolchain problem, which has variously been picked up by people in the past that has never been solved, and why we have this project called JIP Next.
Yeah, there's been the desire to perhaps move to something else, but never enough investment or time to do it.
This was something that Ryan Dahl pointed out way back in his design mistakes in Node presentation.
Yeah, well, I mean, Ryan went through the process with WAF and then JIP, and then
my point is just that like, you know, this is one of those things that's like been, as you well know, is just long-standing, totally fixable if somebody's willing to put in, you know, slog through the hours of like the technical debt and also you know, managing, you know, conversations with people who are going to have opinions.
And the infrastructure. So we had Ben Nordhaus do a lot of work with CMake, but one of the blockers he had was he needed us in the build working group to go through all our hardware and add CMake in as something that could be used. And that was a massive undertaking that I don't think any of us were prepared to chew at. So these things have, it's so complex, and you know, that criticism from Ryan is, yeah, it's right and logical, but this is one of the costs of managing a very large, complex project with stability guarantees that we offer. So,
and to be clear, since we're speaking in public, we're streaming and everything, you know, that was not Ryan criticizing the project as much as Ryan expressing his own, you know, regret about it. But yeah,
it's
anyway.
Ryan expressing something that most of us would express.
Most of us have and will express publicly, yes.
None of us are happy with this state of play. There is disagreement about what's next. We could follow the Electron route of saying, let's just do GN and keep on following Google down their rabbit holes.
Well, that's the biggest. That's the biggest moving target, which is V8. And if we want to keep up with V8, how do we translate their build changes? Because they add a lot to their, you know, each new version of V8 we pick up seems to have new bits of V8 introduced, new things being, things like new binaries being built to build other bits of V8. And at the moment, the team putting the V8 updates in have done a reasonably good job of being able to translate them into GYP, but even that's becoming, you can see it becoming a bit of a strain on them, trying to get V8 building in a different build chain.
It's our COBOL, and we have our specialist COBOL programmers who handle that.
Yes.
Anyway,
most of the other stuff is we do update it, but it's reasonably static in terms of it doesn't really change shape much. So there's obviously effort involved, but it's almost a sort of one-off effort with every now and then little bits. But V8's definitely it's an ongoing maintenance. So whatever we pick, we have to consider how we handle the updates to that, because it's not going to be a do it once and you're done. It's a continuous maintenance job.
Yeah, and then you've got the add-on ecosystem to consider. Like that's a diabolical challenge, that one.
Okay, so it sounds like we're like one of the questions, like in the discussion of which I added the comment, somebody was saying, hey, if you need hardware, I could order hardware. I know we talked about talking to the foundation about hardware, but it doesn't seem like that's our blocker yet, especially since in terms of the virtualization, it sounded like that's not quite ready on the new hardware anyway. Is that still a fair statement?
Right. We didn't have it. Do we have a timeline on VMware, or should we consider a different option? Or
yeah,
I'm not sure we looked at that timeline. We just like, that maybe means we shouldn't rush into, getting separate hardware.
Yeah, I don't think the timeline is very quick. I think the bigger issue would be getting Docker working first, which is facing the same problem because of how Docker runs on a Mac.
Let's see what Docker still uses. Is it VirtualBox or one of the other VMs? So it's all VM problems.
I don't think it uses VirtualBox. But I just wanted to validate, like, I haven't asked the foundation to go and buy any machines yet. I did ask Apple if they would give us any, and they didn't say yes. So it does sound like we'd have to buy our own. But I think first answer is just, Mac Stadium is very generously donating us resources, and so those are actually the easiest for us to manage as well. So I'm kind of like, let's pursue that. And then I know we like to have multiple options, but maybe that we pursue once things have settled down a little bit more. That's at least what I'm thinking. Does that sound reasonable to everybody, or thoughts?
I'm just glad that there's no super urgency for it, and that we have this fallback emulation layer that seems to actually be pretty good.
Mm-hmm. No, that's definitely good. Okay, that was the only thing we had on the agenda. So if that's it, we could close out for today.
Yep.
I'll just give one last thing because I've been working on research. Just a quick update on the metrics, which passed its year anniversary last month. So they've been facing huge issues with streams, funny enough. So been working with Beth Griggs, and we've got our working implementation, which involves downloading a file into memory in a Google function or a Google run It's a Docker container. It downloads the file, converts, reads through, strips all the data out, and then re-uploads it. That works. I'm just facing some. I think there's a memory leak in it somewhere, which isn't good. So I need to fix that first, because otherwise I'll start costing the foundation hundreds and thousands. But it's further than it's been in months, so there's at least something. I ran it over a weekend, and it had data for every 5 minutes over that weekend. So there's some progress there.
Okay, so basically, removing the streams and using a different implementation has given us some good progress.
Yeah, I'm not 100% sure if I can remember what the reason was, but it would just basically crash on the second time the stream was called. There was something dodgy going on. I don't know if it was an error in the code not propagating out or what, but this time around I can catch everything and see what's going wrong.
Well, it sounds good. Sounds promising anyway.
Okay, I have to go, so I'm out anyway. So bye all.
Okay, bye. Anything else before we all drop off? Okay, talk to everybody later.
Bye.
Bye.
Bye.